for the question 1 is explain the meaning of differentiate and what are the techniques of differentiate. Okay, for the explanation, differentiate in calculus is a method used to compute the rate of change of a function fx with respect to its input x. This rate of change is known as derivative of the with respect to x. So the first derivative of any function y equals fx is denoted dy over dx, where dy denotes an infinitesimally small change in n dx and infinitesimally small change in x. It is defined by dy over dx equals limit h approaching 0 function x plus h minus function x over h. About techniques of differentiate. Okay, techniques of differentiate, we have 7 techniques, which is we have power rule, constant rule, product rule, chain rule, quotient rule, constant multiple rule, and the last one is sum and difference rule.
Now let's move to question 2. This question asks us to find the dy over dx for the following functions. Let's begin with part A. We are asked to differentiate the function y equal to 3x squared times secant of x plus 2. As we can see, this is a product of two functions. The first part is 3x squared and the second part is secant of x plus 2. To solve this, we apply the product rule. The formula of product rule is uv prime plus vu prime. Let u equal to 3x squared. So, we must differentiate this to get u prime. So, the answer is 6x. Then, let v equal to secant of x plus 2. To get v prime, we must differentiate one by one. So first, as we know, if we differentiate secant, we will get secant x tan x. So, we will get secant of x plus 2 times tangent of x plus 2. Next, we differentiate the number inside the bracket. So, differentiate x and we get 1, and differentiate 2 we get 0. So, v prime is equal to secant of x plus 2 times tangent of x plus 2. After we get the value of u, u prime, v and v prime, we substitute it into the product rule formula, which is uv prime plus vu prime, to get dy over dx. Wrote down dy over dx equal to 3x squared times secant of x plus 2 times tangent of x plus 2 plus secant of x plus 2 times 6x. Then, we must expand all the value in the bracket to get the final answer. So, the final answer of dy over dx is equal to 3x squared times secant of x plus 2 times tangent of x plus 2 plus 6x times secant of x plus 2. Now, let's move on to part B. In this part, we are asked to differentiate y equal to 4x plus 2 divided by cos x. Since this function is a quotient, we will use the quotient rule. The quotient rule say y over dx equal to vu prime minus uv prime divided by v squared. First, let u equal to 4x plus 2. To get u prime, we must differentiate this value. Differentiate 4x, we get 4, and differentiate 2, we get 0. So, the value of u prime is 4. Next, let v equal to cos x. As we know, differentiate cos x, we will get negative sin x. Therefore, the value of v prime equal to negative sin x. Since all the value needed are obtained, we must substitute it into the quotient rule formula. Dy over dx equal to cos x times 4 minus 4x plus 2 times negative sin x divided by cos x squared. Now, expand all the bracket. After expanding the bracket, we will get 4 cos x plus 4x sin x plus 2 sin x divided by cos x squared. Now, we notice that both terms, 4x sin x and 2 sin x, have a common factor of sin x. So, we can factor it out to simplify the expression. So, the final answer for dy over dx is equal to 4 cos x plus 4x plus 2 times sin x divided by cos x squared.
Let's move to the question 3. So for these questions, we are given an equation that involves x and y, and we are asked to find dy dx using implicit differentiation. So the equation is y ln 3x minus e to the power of 2x plus 1 minus tan 4y equal to 0. So the first step is we need to differentiate each part lah. Since y is a function of x, so when we differentiate y, we must include y prime. So the first term is y ln 3x, and this is two things multiplied, which is y and ln 3x. So we use the product rule, which is the formula is uv prime plus vu prime. Then we find u and the value is y. For the u prime, we got y prime, and for v is ln 3x, while v prime is 1 over x. And we substitute the value into the formula and we get y multiplied by 1 over x plus ln 3x multiplied by y prime. Then we move to the second term, which is e to the power of 2x plus 1. We differentiate this term using the chain rule and we got e to the power of 2x plus 1 multiplied by 2. Then for the third term, which is tan 4y, we use the chain rule again and we got second squared of 4y multiplied by 4y prime. So for this step 2, we need to put all together and we got y over x plus y prime ln 3x minus 2e to the power of 2x plus 1 minus 4 second squared of 4y multiplied by y prime equal to 0. For the step 3 is we need to move the y prime terms to one side and the rest to the other, and it will becomes like y prime ln 3x minus 4 second squared of 4y multiplied by y prime equal to 2e to the power of 2x plus 1 minus y over x. Then we factor our y prime and solve for y prime, and the final answer we will got 2e to the power of 2x plus 1 minus y over x over ln 3x minus 4 second squared of 4y.
For the last question, use linear approximation to estimate the value of fourth root 18.99 minus 2 over square root 80.99 correct to 3 decimal places. So for the first step, we need to find the fx. Replace all the value of 80.99 into x. The question were given in square root, so we need to change it into fraction. Like the fourth root x, we change into x to the power of 1 over 4 minus 2 over x to the power of 1 over 2. We can see that 2 is a number only, so we can move up the x to the power 1 over 2 beside the number of 2. So automatically the power will turn into negative. Next, we move into step 2. We need to differentiate the value of fx that we got just now. So we will get f prime x equal to 1 over 4x to the power of 3 over 4 plus 1 over x to the power of 3 over 2. Step 3, we need to identify what is the x, x naught and delta x value. For the x value, we can got it from the question. So 80.99 is the x value. To find the x naught value, we need to identify the integer that close to the value of x. So the value is 81. And for the delta x value, we need to minus the x value with x naught value. So the answer is negative 0.01. And for the last step, we need to calculate by using the formula of linear approximation. The formula is f x naught plus delta x equal to f x naught plus f prime x naught multiplied with delta x. Then substitute all the value that we got in step 3 into the formula. So f xt1 plus negative 0.01 equal to f xt1 plus f prime xt1 multiplied with negative 0.01. So for the f xt1, we need to write back the equation of fx like in the step 1. And for the f prime xt1, we need to write the f prime x equation that we got in the step 2. Substitute xt1 into all the x value in the equation, and you will got the final answer is 2.778.